Whenever you ask an AI a question, have you ever just stopped and wondered what's really going on in there? I mean, how does it go from a blank slate to this incredible tool that can write code, plan your vacation, or even explain physics? Well, today, we're going to pull back that curtain. We're going to explore the entire life cycle of an AI model, right from the very beginning.
So this is the big question, right? How does an AI go from just reading a giant chunk of the internet to actually answering your specific questions? It's a journey, really. Kind of like a digital education that turns a massive pile of raw data into that helpful assistant you're chatting with. And it all happens in a few key stages. We're going to break it all down into 3 simple stages. First up is pre-training. This is where the model just learns the rules of language. Then there's post-training, which is all about teaching it how to be helpful and follow our instructions. And finally, deployment. That's where you come in, and believe it or not, you play a pretty crucial role. So let's jump in at the very beginning.
Okay, welcome to Stage 1, Pre-Training. Think of this as the model's elementary school. Before it can even dream of answering a question, it first has to learn the basics, like what words are, how they fit together, and all the zillions of patterns that make up human language. And to do that, it needs to read. And I mean, it needs to read a lot.
So what's on this AI's reading list? Well, essentially, a giant slice of the internet. This is its entire diet of information. We're talking a huge mix of stuff. Books, articles, Wikipedia, blogs, and even tons and tons of computer code. The whole idea is to just soak the model in as many high-quality examples of language as we possibly can. But here's the thing. You can't just throw the raw internet at a model. It's a mess. So a super important step is cleaning all that data up. This means getting rid of duplicate pages, filtering out sensitive personal info, and just making sure everything is in a nice, consistent format. Because really, quality in equals quality out.
Now here is a really core concept. These models, they don't understand words like cat or house the way we do. They only get one thing, numbers. So all of that text we just gathered has to be converted into a numerical format. And that process is called tokenization. Let me show you what I mean.
Here's a super simple example of how it works. A phrase like, the cat sat, gets broken down into individual pieces, the tokens. Then, each of those tokens gets its own unique ID number. So the cat sat just becomes a sequence of numbers, like 312, 952, 177. This is the language the model actually speaks. Okay, so the model has its massive, cleaned-up library of the internet, and it's all turned into numbers. But how does it actually learn anything from all this? What's the fundamental task it's doing over and over and over again to build its understanding of the world?
Well, the answer is surprisingly simple. It's called next token prediction. The model is trained relentlessly on one single job. Given a string of words, predict the very next word. That's it. It just does this billions and billions of times.
Take a look at this. If the model sees the phrase, the cat sat on the, it crunches all the patterns it's ever learned. And based on that data, it calculates the probability for what the next word is most likely to be. It learns that mat is a super high probability word, right? Hat is less likely, and bat is even less likely than that. By doing this millions of times, it starts to figure out the relationships between words and the whole structure of language.
And this is the absolute key takeaway. The model doesn't know anything, not like a person does. It is a probability machine. It's just making incredibly sophisticated guesses about what words should come next, all based on the data it was trained on. This explains why it's so powerful, but it's also why it sometimes makes mistakes or hallucinates. And that leads us right into the next stage.
All right, stage 2, post-training. So at this point, our model can create text that makes sense, but it's not really a helpful assistant yet. It's kind of like a student who's read every book in the library but has no idea how to actually answer a direct question. This is where we teach it to be useful.
The first step in this process is something called supervised fine-tuning, or SFT for short. And it's exactly what it sounds like. We have humans create a bunch of high-quality examples, great questions with perfect answers. The model then studies these examples to learn how to follow instructions and give answers that are actually helpful.
And the difference this makes is just night and day. Before SFT, if you ask for a checklist, the model might just give you this vague paragraph about backups. But after SFT, it gets it. It understands the instruction and gives you a clear, actionable, numbered list. It literally learned the format of a helpful response.
This fine-tuning is also how the model learns to use tools. It doesn't just know how to search the weather for today's weather forecast. It has to be shown examples that teach it when to trigger a web search and, just as importantly, how to take those search results and work them into a good answer.
All of this work is part of a much bigger goal we call alignment. Alignment is just the process of shaping the model's behavior so that it matches what we as humans actually want. We want it to be helpful, we want it to be honest, and we want it to be harmless. And there are a couple of cool techniques for doing this.
So two of the most popular methods are called RLHF and DPO. In both scenarios, you have real people in the loop ranking different AI answers from best to worst. RLHF uses that feedback to train a whole separate reward model, while DPO, which is a bit newer, learns directly from which answers were preferred and which were rejected. It turns out to be faster and a lot more efficient.
Okay, so the model is helpful, it's aligned, but what happens when you throw a really complex problem at it? Something that needs multiple steps of actual reasoning to solve. How do you teach an AI how to think?
Well, the secret is a technique called chain of thought, or COT. The idea is, instead of just showing the model a problem and the final answer, you actually show it all the steps in between, the entire reasoning process. This encourages the model to break down problems on its own, and it leads to way more accurate and transparent answers.
This is a perfect example, right? To solve 23 times 47, instead of just giving it the answer 1081, the model is taught to show its work. First, break it down. Then, calculate each part. Finally, add the results together. By forcing it to go step by step, the final answer is much more likely to be correct.
And that brings us to our final stage, which is all about you. Now that you understand how these models are actually built and trained from the ground up, how does that change the way you use them? How can you become a smarter, more effective AI user?
So, let's quickly recap the three most important things to remember. First, LLMs are probability engines. They're not really knowledgeable. Second, it's a two-part education. Pre-training teaches them language, but it's the post-training that actually makes them useful to us. And finally, none of this works without that essential step of fine-tuning with real human feedback.
So what does this all mean for you? Well, first, be specific in your prompts. Now you know why. The model was literally trained to follow detailed instructions. For tricky problems, trigger its chain of thought reasoning by saying things like, explain step by step. And because it's all based on probability, you should always fact-check anything important. And last but not least, remember that you're part of this whole system. Your feedback actually helps these models get better over time.
Let's end on this thought, which I think just perfectly sums up this whole journey. Training an LLM is like raising a child, except the child reads the entire internet, never sleeps, and still hallucinates. It really highlights the incredible learning power these models have, but also that fundamental, kind of quirky, probabilistic nature that we always have to keep in mind. It's not magic, it's just a fascinating, complex, and ongoing education.